This lesson is on isotopes, and this will be just like a basic overview of isotopes. So we're going to start out with some definitions. So atomic number, this is represented by a capital Z. And that might seem a strange letter to use to represent atomic number. Z is from Zahl, Z-A-H-L, which means number in German. The atomic number Z, this is the number of protons in the nucleus of an atom. And our atomic number, the number of protons, this identifies the element. Protons, neutrons, and electrons, it's the protons that identifies the element. All I need to know is the number of protons, and I can tell you what element that atom is. And this number, this is on the periodic table. If there's any numbers on the periodic table, if you have a periodic table that just has symbols, then it's not on it, of course. But most periodic tables have the atomic number. And in fact, the table is organized in terms of increasing atomic number. So our periodic table goes by increasing atomic number. So we start with hydrogen that has 1 proton, an atomic number of 1. Then we have helium with an atomic number of 2, meaning it has 2 protons in its nucleus. Oh yeah, it'd be a good idea for you to have a periodic table on hand for this lesson. That will help. Okay, now what is mass number? Well, mass number, crazily enough, is represented by a capital A. Mass number, this is the number of the protons. Whoops, I forgot the P. Protons and neutrons in the nucleus of an atom. Because they're the particles that are in our nucleus. The protons and the neutrons. So protons are positive, have a charge of +1. Neutrons are neutral, and they do not have a charge. Okay. So our mass number, this number is not on the periodic table. And in a very short amount of time, we're going to see why that number is not on the periodic table. All right, so we have atomic number and mass number. And now we can get to our definition of isotope. So what are isotopes? Well, let's look at the word isotope. This iso, this means same. Like if you have an isosceles triangle, that means that 2 sides are the same length. And topos means place. So specifically, we're talking about the same place on the periodic table. So isotopes, they're atoms of the same element. So if they're the same element, that means they have the same atomic number. So they'll be on the same place on the periodic table because the periodic table goes by atomic number. So they're atoms of the same element with different numbers of neutrons. So this means that our isotopes have, whoops, why did I put S? Our isotopes have different masses. Now, if you learned about John Dalton and his theory of the atom, he thought that every atom of the same element was exactly the same. So now we have a modification to Dalton's atomic theory because of isotopes, because we can have two atoms that are the exact same element that have different masses because they have different numbers of neutrons. The protons and the neutrons are more massive particles than the electrons. So most of the mass of the atom comes from the nucleus where the protons and the neutrons are. All right, so what else can we say about isotope? Well, we can say that every naturally occurring element has isotopes. And I say naturally occurring because we have some elements that are man-made, especially those at the with the highest numbers, the highest atomic numbers. They're all man-made and particle accelerators. So every naturally occurring element has isotopes. And sometimes that's really important, and sometimes it really is not important at all. And we're going to look at why. We're going to look at the different types of isotopes. Okay, so our two types of isotopes, we can have stable isotopes and radioactive isotopes. So a stable isotope, in this type of atom, the nucleus does not change. All right, and then in our radioactive isotopes, now we have an unstable nucleus. And this unstable nucleus changes over time. So this is an unstable nucleus that changes over time. And that time can be really long, like thousands of years, or it can be really short, like milliseconds. And this change occurs by the nucleus emits, so shoots out particles and or energy. And there's different types of radioactive decay, it's called. We're not going to get into that in this video, though. All right, so there are, back to here to the stable isotopes, there's about 252 stable isotopes, taking all the naturally occurring elements that have isotopes, about 252. And then we've got about 87 radioactive isotopes, naturally occurring radioactive isotopes. And then we have many man-made radioactive isotopes. I'm going to do that. We write the element symbol. And then as a subscript in front of the symbol, we put the atomic number. And sometimes you'll see this, sometimes you won't. And then as a superscript in front of the symbol, we put the mass number, and you have to have this. Oops, that's mass number. Okay, so let's do an example and we'll write the symbol. So example, we have an atom of neon with 10 neutrons. All right, so element symbol, neon is Ne. And the atomic number, so we get that from the periodic table. So find neon on your periodic table. It's a noble gas. It's in the last column, group 18. and we see that the atomic number is 10. So neon has 10 protons in its nucleus. Now, we need the mass number. The mass number is the protons plus the neutrons. So we have 10 protons, 10 neutrons. Our mass number is 20. And there is our nuclear symbol. It's as easy as that. And we could also have an atom of neon. With 12 neutrons. So for the symbol of this atom, neon, again, if it's neon, it's got to have 10 protons. If it has any other number of protons, it's something else. It wouldn't be neon. And then 10 plus 12, we will put a 22 here. So these two atoms, same element, different number of neutrons, these are isotopes of neon. Okay, now let's look at another way to denote our isotopes. Write the element name. Hyphen, hence the name hyphen notation, and the mass number. So we don't write the atomic number in this one. So if we go back to those two examples that we had before, the one isotope we would write as neon, N-E-O-N, neon dash 20, and then the other one would just be neon dash 22. And then I have seen a hybrid of the two, so you could see the symbol neon dash 20 or neon dash 22. So any of those ways to designate an isotope are fine. There we go. So how many protons, neutrons, and electrons are in a neutral atom of bismuth-209? All right, so we know that our element is bismuth, so we can go ahead and look at the periodic table for the number of protons. I'm going to designate proton by P+. So look on your periodic table. Bismuth's symbol is Bi, and bismuth, where are we? Is element, there it is, number 83. We have 83 protons. For the neutrons, now this is the mass number. This is 209. This is the protons plus the neutrons. We just found out what the protons were, 83. So if we subtract the protons, we will get the neutrons. So 9 minus 3 is 6, 10 minus 8 is 2. So we have 126 neutrons. And then for the electrons, as long as it's a neutral atom, and that's what they're telling us it is, it's a neutral atom, the protons and the electrons have to be equal. So proton is +1, so we have plus 83. Electron is -1, so we need minus 83, so we need 83 electrons. So this one, write the nuclear symbol for the radioactive isotope that has an atomic number of 53 and 78 neutrons. Okay, so now we're given the atomic number. So to get the nuclear symbol, we need the symbol of the element. So we go to the periodic table and look for element number 53. And we see that that is iodine. So iodine's element symbol is I. 53 protons, we can put 53 down here. And then we have 78 neutrons. We need the mass number, which is the protons, 53, plus the neutrons, 78. So that's 11, carrier 1. So we get 131. So that is our answer right there. You can see if we take the top number minus the bottom number, we get the number of neutrons. Now, sometimes you don't see the bottom number because it's kind of redundant. If we know the symbol's iodine, it has to be an atom with 53 protons. So you might see that as 131I. These mean the same thing. And I'm very familiar with this isotope because I had radioactive therapy after thyroid surgery. So I had to ingest some radioactive iodine. Okay, so what you can do is pause the video and then go ahead and do these on your own and then come back and we'll take a look at the answers. So go ahead, pause the video. All right, so hopefully you've done them on your own and now you're back. So here we have an atom of zinc with 36 neutrons. So our nuclear symbol, zinc, is Zn. Zn. Zinc on the periodic table is element 30. 36 neutrons plus 30 protons means our mass number is 66. Or we could write that for our hyphen notation is zinc-66. It's always the mass number that goes here in the hyphen notation. All right, B, an atom with 47 protons and 61 neutrons. Okay, so to write the symbol, we have to figure out what element has 47 protons. So we look on our periodic table, and element 47 is silver, which is a G. So 47 protons, and then to get the mass number, we add 47 and 61, and we get 108. And then our hyphen notation is silver hyphen 108. An atom with a mass number of 52 having 23 protons. So again, look on the periodic table for element number 23, and that is V for vanadium. We have 23 protons. The mass number is 52. So we don't have to do any subtraction there, 52, 23V. And to write the hyphen notation, V is vanadium, vanadium dash 52. Okay, now we'll do our second part, and I'm just gonna erase this so I have room to do the work there. Okay, now we're going to determine the protons, neutrons, and electrons. Just maybe make a little chart here. Protons, neutrons, and electrons. So we're doing tin 120. All right, so tin, look on the periodic table first. What is the symbol of tin? So tin is Sn, and it is element number 50. So tin has 50 protons. We're going to assume we have neutral atoms. I'll do ions in another video. So if we have 50 protons, we're going to need 50 electrons so that we have a net charge of 0. Now the neutrons, we take the mass number, protons plus neutrons, minus protons, so we end up with 70 neutrons. So that's the answer to A. Okay, for B, we have 133 CS, and there's no atomic number here, but that's, you don't actually need it because just knowing that we have cesium, CS, we can just get it right from the periodic table. So we look in the periodic table, cesium is element 55. So that means we have 55 protons. And of course, we're going to need 55 electrons to maintain electrical neutrality for a neutral atom. And then we have to get the number of the neutrons. So our mass number is 133 minus 55, 13 minus 5 is 8, 12 minus 5 is 7. So that means that we have 78 neutrons. For C, now this is that like hybrid notation. So S is sulfur. We look on the periodic table for sulfur, and we see that its atomic number is 16. So it has 16 protons. So of course it has to have 16 electrons. And then 32 is the protons plus the neutrons. So 32 minus 16, we have 16 neutrons as well. And then for D, 23 Na, and Na is sodium. Sodium is element number 11, so we have 11 protons in the nucleus, and then 11 electrons surrounding the nucleus for neutral sodium. And then for our neutrons, 23 minus 11. So we get 12. And that's it. So that is how we write symbols and figure out particles for isotopes.